Okay, good day everyone. So here we are today with this lecture for our physical science discussion. So for today, we will have the topic properties of liquids and intermolecular forces for physical science 11. So I hope that everyone will be able to listen and understand this lecture so that on our next meeting on Wednesday, we will have a short quiz about intermolecular forces and this lecture on the properties of liquids. So for your learning targets for this lecture is you have to describe the properties of liquids and to explain the effect of intermolecular forces to these properties. So aside from the properties of liquids, we will relate how these properties are being affected with the existing intermolecular forces among these liquids. So the different properties of liquids, we have the surface tension, the capillary action, viscosity, vapor pressure of liquid, molar heat of vaporization, and the boiling point. So first things first is the surface tension. So when we say surface tension, it is the measure of the elastic force in the surface of your liquid. So for instance, katong photo wherein a um, paper clip is on the top of the water without sinking. Nara siya sa babaw. Wala siya sink, wala siya ni ito sa ilalim, nara siya sa ibabaw. It's because of the surface tension that is existing within the water. So ang katong surface tension or the elastic force on the surface of the water is not broken. Mo nang ang paper clip is still on the top of your water. So another definition, when we say surface tension, it is the amount of energy required to stretch or increase the surface of a liquid by a unit area. So it is manifested as some sort of skin on the surface of a liquid or in a drop of liquid. So mo to akong example, kaning paperclip on the top of a water. Then also, kana ato ang makita nga droplets of water on a leaf and kaning water on the top of a coin. So liquids that have strong intermolecular forces also have a high surface tension. Taas-taas sila og force, kumbaga. Next property is the capillary action. So when we say capillary action, it is the tendency of a liquid to rise. So musaka siya in narrow tubes or be drawn into small openings, such as those between grains of a rock. So when we say capillary action, it is also known as capillarity. So it is a result of the intermolecular attraction between solid and liquid materials. So an example of capillary action is when we are kanang kuhaan og dugo, like this one, and then this liquid in a tube, and these inks being scattered in a tissue paper because of kaning alcohol or the liquid in the cup no na nakapa-disperse sa ink mo nang nikatag ang separate na colors sa tissue paper. So nisaka ang liquid from this point pasakaan ng tissue paper. So once kinabasa ang ink dira amo nang manggawas, nanggawas ang iyang different na content na color sa tissue. So there are two types of forces that are involved in the capillary action. So we have cohesion and adhesion. So when we say cohesion, it is the intermolecular attraction between the like molecules or the liquid molecules. So ang attraction between the liquid molecules is called the cohesion, whereas the attraction between unlike molecules, like for example, sa sudlanan niya and the liquid itself, it is called the adhesion. So these forces also define the shape of a surface of a liquid in a cylindrical container, like looking at the meniscus of a liquid in a test tube. So for example, this one. So when the cohesive forces between the liquid molecules, when no, ang cohesive forces is greater than the adhesive forces, for example, the liquid inside this test tube, between the liquid and the walls of the container, the surface of the liquid is convex, just like in the mercury in a container. So mas kusog ang cohesive forces between the mercury molecules against the walls sa container niya nga test tube. Whereas, on the other test tube, if ang cohesive forces between the liquid molecules are lesser than the adhesive forces between the liquid and the walls aning test tube container, the surface of the liquid is in concave na forma, like the water in the glass container or this test tube. So if equal ang forces between the liquid and the container itself, horizontal siya. Walay pa bawog sa ilaw or pabawog pa babaw. Next property is the viscosity. So when we say viscosity, it is a measure of a fluid's resistance to flow kanang pagkalapot sa usa ka liquid. So the greater the viscosity, the slower the liquid flow. So kung mas malapot ang usa ka liquid, mas of course slow siya mo dagat. So viscosity is expressed in units of centipoise. So water has a viscosity of 1 centipoise or 0.001 Pascal per second at 20 degrees Celsius. So substances with lower viscosities include carbon tetrachloride and benzene. So these are examples of viscosities of liquids of the selected substances. So we have acetone, very gamay ang iyang viscosity, -4. Water has also a lower viscosity, 1.01 times 10 to the power -3, with glycerol, 4.9 ang iyahang viscosity. So among these liquids, si glycerol ang pinaka-viscous compared to the other liquids in the table. So given the molecular structures of water and glycerol, can you tell why glycerol has a higher viscosity than water? You may pause this video and think about how the molecular structures given can affect the viscosity of a certain liquid. Okay, so as you can see in this illustration of the structure of water and glycerol, the larger amount of OH group or oxygen and hydrogen groups allow the glycerol to form more hydrogen bonds with other glycerol molecules. That is why its intermolecular forces are stronger, of course, compared to water. Therefore, glycerol has more resistance to flow. Another is we can also tawag ani, differentiate the viscosity of these liquids with mas taas or mas daghan og hydrocarbon na series. Like for instance, if a liquid has 1, 2, 3, 4, 5, 6 ka carbon or hexane siya. So asa may mas viscous compared sa decane na naay napulo ka carbon. Okay? So the size of the molecules is mag-vary sa kaviskusa sa ka liquid. So the larger the molecule, even if it is non-polar, the stronger the intermolecular forces and the greater the viscosity compared to non-polar substances made up of smaller molecules. So magkadaghan ang iyang carbon or magkadako siya na molecule, mas magka-viscous siya. Mas taas ang iyang resistance to flow. No? Negative 4 man diha, negative 3 diri. So therefore, mas dako og viscosity value si decane compared to hexane. So, question, what effect temperature would have on viscosity? So, kung init or kung bugnaw siya, na ba siya effect with the viscosity of a liquid? So, of course, yes, there is an effect of the different temperature towards viscosity. So, if the temperature increases, nisa ka siya, ang viscosity mo baba. Whereas, katupong bugnaw or the temperature is mo decrease, ang viscosity po nato mo increase. So, baliktad siya. There is an inversely proportional na relationship between viscosity and temperature. Okay. So kung tanawin mo diha ang water, it only have 1 centipoise compared to lava which has a 4,300,000 centipoise ang iyang viscosity. Viscosity lava. So vapor pressure of the liquid. Now, next na property of your liquid is the vapor pressure of a liquid. So when the rate of condensation of the gas becomes equal to the rate of evaporation of the liquid, the gas in the container is said to be equilibrium in the liquid. So equal na equilibrium if ang rate of condensation is equal to the rate of evaporation. No, while nag-escape and all, there is said to be an equilibrium in the liquid. So in this condition, the amount of gas and liquid no longer changes because of the equilibrium between the evaporation and the condensation of the gas and the liquid. So in the vapor pressure or the pressure of the vapor itself, no, ang ihapong relationship is that the greater the number of gaseous particle, the greater the pressure is exerted by the gas. So kung mas daghan gas particles, of course, mas taas po na siya og pressure. So the pressure exerted by the gas in an equilibrium with a liquid in a closed container at a given temperature is called the equilibrium vapor pressure or simply the vapor pressure of the liquid. So kung ang equilibrium vapor pressure or vapor pressure itself is equal to the maximum vapor pressure of a liquid at a given temperature. So kung musaka ang temperature, musaka pud ang pressure sa usaka liquid. So vapor pressure is independent of the amount of liquid as well as the surface area of the liquid in contact with the gas. So pahalagahan pa ng liquid dira, dili siya magdepende sa kadaghanon sa amount of liquid. So magdepende siya sa increase of temperature. Ayun. So for a graphic or visual representation of the relationship between vapor pressure and temperature. So the more magkataas ang temperature, magkataas po ang vapor pressure. So ang atong vapor pressure is calculated or asa tawag na? Measured through ATM or atmosphere, ang iyang unit. When temperature is high, more molecules have enough energy to escape from the liquid. So the lower temperature, mas gamay nga molecules have sufficient energy to escape from the liquid. So no need na nga taas ang iyang pressure. So, if the vapor pressure is somehow related with its temperature of the liquid, so naapod siya relationship when it comes to the existing intermolecular forces of the liquid. Okay. So, for example, the stable with the different substances and their equivalent vapor pressure at 25 degrees Celsius. So, equal na temperature. So, when liquids evaporate, the molecules have sufficient energy to break the attractive forces that hold them in the liquid state. So, kung evaporate, for example, kintahay ang tubig. No? Of course, na siya level of energy no, para mo break na ang liquid para mahimong gas. Okay? So, in comparison to other liquids, now the stronger these intermolecular forces are, nag-exist na ang liquid, the greater the amount of energy needed to break them. So, pasabot, mas taas na pressure po ang kinahanglan para ana nga um, tawagan ni liquid to break from its previous state, from liquid para mahimo siyang gas. So for some substances naman, na weak po ang ilahang intermolecular forces, so the energy requirement is easily obtained from collisions with other molecules and absorption of energy from the surroundings. So no need na nga musaka ang iyang vapor pressure because weak man siya daan og intermolecular forces. Next is the molar heat of vaporization and the boiling point of your liquid. So the relationship between your vapor pressure and the strength of intermolecular forces is consistent with the trends in two other properties of liquids. So we have the enthalpy or the molar heat of vaporization. So other term for molar heat of vaporization is enthalpy. So the enthalpy and boiling point of the liquid is somehow related to each other. So why and how? So when we say molar heat of vaporization or illustrated with this unit HVAP, is the energy required to vaporize 1 mole of a liquid at a given temperature para mahimo siyang kuan, gas, kumbaga. So H is the symbol for enthalpy, which means heat content at a given standard condition. So the heat of vaporization may be considered a measure of strength of the intermolecular forces in a liquid. So if strong ang intermolecular attraction, it takes a lot of energy to be freed from molecules from the liquid phase and the heat of vaporization will be high. Sa katong akong explain kagaina, no? The more nga taas or strong ang intermolecular attraction, ang ang energy po na needed to break those molecules apart will also be high. So therefore, in this case, the heat of vaporization will also be high. So for example, it is easier to vaporize acetone than water. No, for example, mabutang taog acetone sa tong kuko or sa katong kamot itself. Sa pikas kamot, acetone sa pikas kamot water. At a given temperature, normal room temperature. So asa may una mahubas or mauga sa ato ang kamot, ang acetone ba or ang water? No? So technically, si acetone ang unang mawala or mauna mo vaporize compared ni liquid water because si acetone has weaker intermolecular forces compared to water. No, acetone is also a polar substance but has no hydrogen bonding. So it has weaker intermolecular forces than water, and therefore acetone molecules are held less tightly to one another in the liquid phase. So siya ang unang mo vaporize. Next point is your boiling point. So of course, the boiling point of the liquid is the temperature at which the liquid converts into gas. So kanang point mo hit na ang liquid ana, mag-slowly turn na siya into gas. So a liquid boils when its vapor pressure equals the pressure acting on the surface of the liquid. So the boiling point is the temperature at which the vapor pressure of the liquid is equal to the external pressure. So mo na to murag moabot siya sa point na equilibrium kumbaga nga ni equal na ang pressure nga nasa sulod sa giboil nga liquid ug ang pressure nga nasa gawas sa container sa liquid. So a normal boiling point is the temperature at which the liquid converts to a gas when the external pressure is at 1 atmosphere. So the normal boiling point of water is commonly known at 100 degrees Celsius. So boiling point, the molar heat of vaporization. So we have here the value of the different boiling points at Celsius, no, of the different substances in comparison to its molar heat of vaporization. So unsa yung nabantayan sa substances with their boiling point and molar heat of vaporization? For example, sa water, na siya 100 degrees na boiling point, then ang iyahang molar heat of vaporization is 40.79 kilojoule per mole. And compare it with, ato lang ingnon, mercury. Kung ang boiling point sa mercury 100 degrees, 357 degrees Celsius, naapod siya molar heat of vaporization na 59 kilojoule per mole. Kung ethanol po, 78.3, naapod siya ay 39.3 kilojoule per mole. So sa inyo mabantayan na pattern between these substances and relationships sa boiling point and the molar heat of vaporization. So, makita ninyo na the more nga magkataas ang ato ang value sa boiling point is magkataas po ang iyahang molar heat of vaporization. It is related or directly proportional to the heat of vaporization. So the higher the HVAP, the higher the boiling point. The boiling points of substances often reflect the strength of the intermolecular forces affecting or operating among the molecules. So pasabot, mas strong ang intermolecular forces ni mercury compared ni water. Mas strong ang intermolecular forces ni diethyl ether compared ni argon. Mas taas ang intermolecular forces ni ethanol compared ni diethyl ether because mas taas man siya ang boiling point compared ni diethyl ether. Nakuha? No? You can replay this video as long as dili pa kayo masabtan ang concept. So at BP or the boiling point, enough energy must be supplied to overcome the attractive forces among molecules before they can enter the vapor na phase po dayon. So nga naman sa tanang liquid is ato amang basis is si water. So of course, water has its many uses. Now it is considered in chemistry as a very unusual, very common na liquid or base in everything na ato ang kinastudihan. So water also is an essential substance to life. It is most important or abundant compound on Earth and comprises about more than 60% of human body. So atong lawas is halos more than half of our body is composed of water, H2O. But it is also one of the most unusual substances on Earth. So why? Because number one, the unique property of water is that it is a good solvent. Also, water has a high specific heat. Its boiling point is unusually high compared to those normal na mga liquids. And in solid water, no, if ang water is in solid form, less than siya. No? Nga naman na siya, basically solid siya, ano mo less than man siya compared sa liquid water. So it is the unique property of your water. So before we end this lecture, let us have a short recap of the different properties of liquids in respect to the work intermolecular forces. So first, number one, we have surface tension. Second one, we have capillary action. Third is the viscosity, the viscous, the stronger the intermolecular forces, the viscous the liquid. The surface tension, the stronger the intermolecular forces, the stronger the surface tension. Sa capillary action, sa ganito sa capillary action, it depends on the intermolecular forces of the liquid if it exists stronger cohesion or adhesion towards its tawagan na, container. Number four, vapor pressure of the liquid, the pressure of the liquid itself, the molar heat of vaporization or the enthalpy existing in the liquid. And number six, we have the boiling point. So boiling point is related to the molar heat and of course also with the vapor pressure of the liquid. The stronger the intermolecular forces existing in the liquid, mas taas ang boiling point niya. So questions and clarifications. If you have questions, concerns, clarification, you may chat it in the chat box or in our chat box. I mean in our group chat para ma-tackle. And if not, that ends our lecture for this meeting. So thank you for listening and God bless.